you add and divide. The mean is the one in the middle of the line. The mode is the one you see most of the time. Mean, median, mode. Mean, median, mode.
Very good. Everyone give him a hand. Oh, let's try that again. Okay, so the measure of central tendency is mean, median, and mode. Okay, mean is the one that you add and divide. Right, it goes mean, median, mode, mean, median, mode. This is what they are. This is what they are. The mean is the one that you add and divide. The median is the one in the middle of the line. The mode is the one that you see most of the time. Mean, median, mode. Mean, median, mode. See? 3 blind mice, right? 3 blind mice. I don't know the song though. Yeah. But anyway, so that is the song for mean, median, mode. Okay, the mean is the one in the middle of the line. We'll explain that in a second. The middle of the line, when the numbers are in order. From greatest, not greatest, least to greatest. Yes. No. Okay. That part of it doesn't fit into the song, so we just write it in. Okay, the mode is the one you see most of the time. It repeats the most. Okay, so the mean, we're going to add up all these numbers. So everybody add up all those numbers. I know. Thank you. Rebecca, what did you get for your answer? 216 if I add them all up. And then you divide by the number of numbers. So how many numbers are there? And you should get 18. Okay, so the average of all those numbers are 18. Okay, the median is the middle of the data, so we need to put these in order from least to greatest. So 14 is first, then I have 15, I have 15, I have 15. Let me cross them off as I go. Then I have 16, another 16. Then I have 17. Then I have 19 twice. Then I have 20, 21, 29. Okay. So I get them all. We're all good? Okay. So then you just take turns crossing them out. So you go 14, 29. 15, 21, 15, 20, 15, 19. Then we're going to go back to blue, 16 and 19. Okay, now these two are in the middle. Okay, so you're going to add them up. Take 16 plus 17 and divide them by 2, and you'll get 16.5. Well, if there's two numbers, right? Since there's two numbers, I'm averaging it, basically, averaging the middle. Okay, so sometimes you'll get left with just one number in the middle because there'll be an odd number of numbers, and that will work out for you. Okay, or you'll sometimes get left with both, so you have to add them and divide by 2. Any questions over that? We're all good? Okay, what is the one that we see most of the time? 15. 15 is seen 3 times, so that is the mode of this data set. Then you have 2 modes. That's the next question. A bimodal data set has 2 modes. So when the numbers has the same amount, so say 16 had an extra one, 15 and 16 would be bimodal. Okay. Any questions over that? Okay, then let's talk about, if we notice all those measures of central tendency were different. So why are the measures of central tendency different? Everyone answer these 2 questions. And when would you use different measures of central tendency? Okay, Braden, why are the measures of central tendency different? Okay. Okay. Omar, what did you put? Why are these different? You're measuring different things? Very good, right? You find them in different ways. Okay. Haley? Okay, the average is done most commonly. Okay, when would you use different measures of central tendency? When would you use the mode versus the mean versus the median? Bailey, Webb, any ideas? Okay. Braden? When asked you to, yes, yes. When you're trying to find different things. We're all trying to find an average, basically, right? The most common answers. What do you think? Okay, so here's the big concept, you guys. The measures of central tendency are all, the goal is to find the most common answer, or the middle of everything, of what's the average data, okay? Obviously, we usually take the mean to find the average, okay? But what if, let's say, you guys are very familiar with our test, right? Out of 100%, basically. If I give a test, and I give you guys the test to find the average of that test, okay? If I gave you a test and I have one person who scored a 32% on it, okay? Because they just guessed. They just circled answers. Would that affect my mean, my average? Yes. Would I necessarily get a good average from that? No. Okay? Because if only one person scored like a 30% on that, that's really skewing my data lower, right? Would I want to then maybe try and find the mode for that, or the median for that? Okay? The mode you might see because, okay, I could then find what they did mostly. What, as a class, mostly who got 78%, or the 77 might be the done most. Okay, C should be the middle, right? In theory, for a good test. Okay, so that's why you're going to use them differently. So if you have outliers, numbers that are really smaller or a lot bigger than the rest of them. Because we could also have it the other way. What if someone scored 100% on it, okay, and everyone were more down to the 70s? Would that skew my data up? I might like that because, yeah, I want to show that my kids got it the best, okay? But it wouldn't truly tell me what my class as an average understood. Does that make sense? Okay. So write down something like that, you guys. Also, the range could also have an issue with your measures of central tendency. Mode is most. Okay, stem and leaf. You guys remember this? Okay, I'm going to show you a few different ways to organize your data, to view it. Okay? So, let's start with the stem. Those are the tens, place value. The leaf are the ones. Okay, so you have, just for this set of data, we have 1 and 2 as our tens. Then our leaves are going to be all of the numbers. You want them in from least to greatest. So 14 is the smallest, so you do 4. Then you have 5. Then you have 5. Then you have 5. You're going to repeat it, even though it's there, because you want to see how many fall within these values. Does that make sense? From here. So 14 is 1 for the tens, place value, and 4 for the ones. 15 is 1 for the stem, and then this, okay? And I'm going to cross out all the ones that I've done already. We're going to do 16, then 16 again, then 17, then 19, and 9. Then 20 is 0, and 1, and 9. Are we good? And that's the stem and leaf. So where does most of my data fall in? The tens. That's how we look at it to see, okay, most everyone was somewhere within the tens place value. If you have a lot of data, that helps you see where most of your numbers are falling again. So you can kind of see averages overview. Okay, quartiles. I'm just going to have you write down these definitions. Okay, so write down the quartiles, the value that separates the data into 4 parts, quartile 1, quartile 2, quartile 3. That's what you're writing down. Then another way to display data is using a box and whisker plot. A method of displaying the data using quartiles to form the box and the minimum and maximum to form the whiskers. There's not a Q4, and I'll show you when we make it what the Q4 actually is. Okay, don't write down this other stuff yet. We'll do that together. Just get the definitions of quartiles and the box and whisker plot. Okay, so I'm going to start by putting the numbers in order from least to greatest, or smallest to biggest. So my smallest one is an 85, it looks like. 81. Thank you, let's put 81 fun. Then 85. Then 88. Then 90. Then 91, 94, 95, 97, and then 100. Do I have that right? Yes. Okay. So now we're going to find the median of the data. Okay, the quartile 2 is just the median, the middle. Okay. So you're going to do the 81 goes away, the 100 goes away. The 85 goes away. Then the 97 goes away. The 88 goes away. Oh goodness, change colors. 88, 95, then 90 and 94. So 91 is the median of the data, is this quartile 2. Then we're going to find the median of the bottom half of the data. So now we're only going to look at this part here. And we're going to find the median of that. So we're going to do the same thing. I'm going to go here and then here. And since I have 2 in the middle, I need to add 85 plus 88 and divide it by 2. And I should get 96.5, is that correct? Oh, thank you, 86.5. Which is what I meant. Okay, that's quartile 1. Now we're going to do quartile 3 too, is by taking the median of the top half of my data. So then I cross out, and I left with those 2. So we do 95 plus 97 divided by 2. And the middle of those 2 numbers is 96. Correct? Okay, so just so you know, write this down. Let's pretend my data was 1, 2, 3, 4, 5, 6, 7, 8. Okay, write this down just so you know what happens. Okay, and I crossed out my numbers. 1, 8, 2, 7, 3, 6, and I got the middle. Okay? So the quartile 1 would be 4.5, right? When I'm going to find the quartile 1 and the quartile 3, I take the middle of these and down. And then I take the middle of this and up. Because 4.5 is in between those 2 numbers. Does that make sense? Okay. That's only been a little tricky in your homework. Okay. So now we also have to find the minimum values and the maximum values. So class, what's the minimum? What is it, class? 81. What's the maximum, class? 100. Okay. I'm going to scroll down. I'm going to write those numbers again. So 81 and 100. Then I have quartile 1 was 91? No, 86.5. Quartile 2 was 91. And then quartile 3 was 96. Everyone with me? Okay, we're going to create a number line now. It says draw a number line for the base of your box and whisker plot, making sure it covers the whole data set. It's not straight, is it? There we go. Okay, I'm going to count. We want to make sure it goes below 81 and goes above 100 just to make it look nice. So I'm going to start at 70. Then I'm going to count by 5, 75, then 80, then 85, then 90, and 95, then 100, 105, let's do 110. Okay. Have it with me. And then make little arrows at the end so it's a number line. So then we're going to start by drawing vertical lines at quartile 1, quartile 2, and quartile 3. Just so I have room to gauge it. I want to make sure all my data fits on it, and I want a little bit below and a little bit above it. Okay. So then 86.5, I'm going to go over here, and it's a little bit above the 86 or 85, and I'm going to draw a line. Okay. Then I'm going to go to where 91 is, which is a little bit above 90, and draw a line above that for quartile 2. Then I'm going to go to quartile 3 and put 96, a little bit above 95. Draw a line above that. Then I'm going to box that in. I'm going to label Q1, Q2, and then Q3. Any questions over that? Okay. The final thing we need to do is add the whiskers. Put dots above the minimum and maximum values and connect the dots to the lines. So at 81, I'm going to draw a dot. And at 100, I'm going to draw a dot. And this connects it. Come on, connect it. So here's my box and my whiskers. Okay. Now this demonstrates a pretty accurate group of numbers. Okay, that have good averages. There's no really outliers. It's not skewed that much because everything seems pretty equal. Right? The minimum value seems about the same distance as the maximum value is away from your data set. Okay, the Q2 seems about in the middle of all your data, right? Q1 and Q3 seem about the same. It's a little bit bigger on between Q2 and Q3, but not too much. Okay. So when you look at this, let's say that you scored, what were the numbers again? The 85. And you want to see where you fall in with all the other data. So you go find 85, and you can say, okay, well, I'm at the bottom part. I'm at quartile 1 and below it, okay? If I was at another one, I could say, okay, I'm in between quartile 1 and quartile 2, so that's quartile 2. From here to here is quartile 3, and from here to here is quartile 4. That's why you only need 3 of them. Does that make sense? Okay. And so this way you can just see in relation to everybody else how you deal with. Okay, so you need to remember back to, remember when you used to take the STAR testing, like 3 years ago? Okay, and you would get, I don't know if you guys ever saw this, but in the mail they would send you data about your test results. Okay, it's usually about the beginning of the following year after you've already taken it. Okay, and they would give you all kinds of charts like this. I feel like they do give you a box and whisker, they used to. Okay, where you could see where you fall in. Because standardized test is not just a blanket, did you get 100% or not? It's how did you do in relation to everybody else who took that test. So you're not compared against a standard of 100. You're compared against what did everybody else do on this test. Okay, and so that's how quartiles can do. How are you comparing to everybody else's data? Okay, any questions over that? Okay, moving on. Okay, a histogram. To make this easier, we're going to get rid of these 2 numbers. I just don't have the room, so just cross up those last 2 numbers for this histogram, because I can't fit it on here. Okay, a histogram is kind of like a bar graph. Okay, you're going to group numbers together in ways, and however you makes it work. Okay, for us, we're going to group it by tens. Okay. Okay, so we're going to go 0 to 10. Okay, then we're going to go 11 to 20. Then we're going to go 21 to 30. Then we're going to go 31 to 40. Then 41 to 50, then 51 to 60, then 61 to 70, then 71 to 80, then 81 to 90, and then 91 to 100. Okay, we're all good? No, you can, because what if your data set's like 1 to 10? So you can break it into smaller pieces and just do 1, 2, 3, 4, 5. Okay? However you group it, however you want to group it. Yes, you just want to make sure if everything can fit in into your numbers. No. Okay, yes. No. Okay, that's now finished. Now we're going to group them, okay? So now you're just going to place all the numbers where they go. So 2 falls here, right? So you just put X's for, and I already did 2. 12 falls in here. 17 also falls in here. 20 falls here. Okay, 22 goes here, 28 goes here, 32 goes here, 37 goes here, 38 goes here. Okay, 41 goes here, 44 goes here, 51 goes here, 53, and then 59, and then 62 goes here, then 78 here, then 86 goes there, and then 92. Okay. But looking at this, what does this tell me? Okay, most of my data falls right here, like you're saying, between 11 and 60. Okay. And that's what it's meant to show you, where most of your data falls. How big your range is, okay, what's going on here. Okay. It's just, again, a way of grouping things so it's easy for you to look at and see what your common answers would be. So then if this was like a test score or number correct or something, you could look at this and be like, okay, well, most people got this, okay? Only a few people got these, but most of us got these. Does that make sense? Okay. Percentiles. Let's give you that. You should be very familiar with percentiles because this is what most of your state tests come back to you as, percentiles. Right? Do you guys remember being like, oh, I'm in the 52nd percentile? Okay? We're going to show you how they came up with that answer. None of you were ever in that percentile, but oh, good. Okay, so to write this down, percentile divides the data into 100 equal parts, where the percentile of a given value is determined by the percentage of the values that are smaller than that value. For example, a test score that is greater than 95% of the scores, of all the other scores, is 95 percentile. So just write down that definition, and then we'll explain how we do that. Okay, so then we're going to find the 20th percentile. Okay, how many numbers are there? There should be 20 numbers. Okay. To find the 20th percentile, multiply the number of numbers by 20%. So there's 20 numbers, and you're going to times it by 0.2. and that should give you 4. Okay. Then go to the 4th number, and the 1 above it is the 20th percentile. Okay, so we're going to go 1, 2, 3, 4, and the 1 above is the 20th percentile. Any questions over that? Yes? If they're asking for the 20th percentile, yes. If they're asking you for the 30th percentile, then you multiply by 30. If you find, it depends on what percentile you're finding. Okay, any other questions? Okay, so that means if you scored a 22, that means you scored above 20% of everybody who took it. Okay? If you scored less than that, then you scored less than 20% of the times. Does that make sense? Less than 20% of the people.
Why did you multiply times?
Because that's 20%. And I'm looking for 20%. Multiplied by that percentage. But as a decimal, because, right, we don't multiply by percentage, you have to multiply by the decimal. Well, then when you multiply it, the 4th one and the 1 above it is the 20th percentile. Because this guy is above 20% of the other people. Okay, so now find the 80th percentile, you guys. Find that. So to find the 80th percentile, you multiply the number of numbers, which is 20, times 0.8 because you want the 80th percentile, and that'll give you 16. So you go to the 16th number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and then 1 above it. So the 80th percentile is 86. Any questions over that? Okay, outliers are numbers are bigger or smaller than most of the data. So it's that student who scores a 30% on a test. It's a lot lower than a majority of your test scores are. Okay. Or if you're looking at average speeds, it's the one person who really speeds through. So on the bottoms, find the outliers in those data sets. So look at these numbers. Okay, class, and what's the outlier here? 3. It's a lot smaller than the rest of the data. How about this? 78. Okay, that's the outlier because it's a lot bigger than most of the data. Any other questions over that? Okay. You guys have your homework. You can work on that for a little bit. And then we'll go over the night before's homework.